Right, good morning. So what I'm going to try and do in the next 15-20 minutes is just give you a couple of things really, just a quick overview of what our outputs are going to look like, the broad form they'll take, and then just to run through and give you a flavour of what we're going to be saying in our narratives about relevance to safety. And in a time-honoured fashion of a sort of a long-running serialised programme, my challenge is to whet your appetite, but give you absolutely none of the juicy bits, because that's the next episode, which we're not allowed to give you today, as Umran alluded to earlier. So very early on in the process of thinking about all this, we recognised, as Bruce alluded to, that we needed to provide this information in a tiered manner, so that everybody could access the key messages and conclusions, but if people wanted to dig deeper with a little bit more knowledge, they could. And what you've seen from Fiona and Dave is that the BGS technical information reports kind of provide that very detailed kind of underpinning for geologists. But what we are going to then do at RWM is kind of address some of those other tiers. And the two key ones really are for technical people who aren't geoscientists, the sort of the new scientist level, as Bruce described it, and then the lay people. And largely what Jonathan's going to be aiming at and talking about later is some of the things we're using to address those the lay people. But the narratives that we've produced are in the main part aimed at that middle level, if you like. And what we've done, given that our focus is very much on the relevance to safety, we're the experts in geological disposal, the BGS are the experts in the geology, but we do recognise that we were the ones that needed to also make some of that geological information available to that middle tier, if you like. So one of the things that we will be producing, have produced and are going through the finalisation of, are 13 sort of regional summaries, 5 to 6 pages of text, that kind of level, which kind of summarise the geological attributes for each of the 13 regions from the BGS work. But then really the main part of what we're doing is then narratives that focus on the relevance to safety for a geological disposal facility. And what we've done there, and again Bruce alluded to this, in fact he stole most of my thunder earlier I think, so, is that we've actually looked at the regions and we've divided them into sub-regions based on similar geological attributes. And really the aim there is it's a national exercise, but what we're doing is reporting it in a way which kind of breaks it down into bite-sized chapters which are appropriate to people living in different areas. And the obvious thing to do is very much it's about the geological attributes and their relevance, so the way we've split it up is based on areas of similar geological attributes. And that means that we've ended up with 45 sub-regions across England, Wales and Northern Ireland. And each of those narratives is approximately 2 or 3 pages long, and is supported by maps of the geological attributes that Fiona and Dave were talking about, so examples given there. So that's really the sort of the shape of it that's aimed at the new scientist level, the technical people but aren't geoscientists. But then what we do on the actual website that we're developing is that there'll then be a half to 1 page summary in layman's speak of each of those sub-regional narratives. And those are presented in 2 ways, in text, but also as videos where a member of RWM will talk through those high-level conclusions with the maps in much the same way as you see the weather forecast being given on the television. The other thing to just point out, and this is the last thing about the structure, is that throughout the written material in these narratives, plus also on the web pages themselves, there will be coloured wording, such as groundwater or hydraulic separation or some of these terms. You'll be able to click on them and take them to the videos that Jonathan will be giving some examples of later. So the idea is to try and keep the amount of jargon, if you like, the technical jargon to a minimum, but where certain words have to be used, the aim is to actually provide videos and other material to support that. So that's really just the shape of our outputs and how we've worked on that. So what I'm going to do now really is just have a very gradual stroll through these topics and just touch on the sort of things that we will be saying about the relevance to safety of these different geological attributes within these topics. So I think all three of the people before me have gone through the three different rock types, the broad rock types that could potentially host GDF, so I'm not going to say too much about those, just other than to focus in, and for each of them just say the sort of thing that we'll be touching on in our commentaries. So for lower strength sedimentary rocks, we provide a commentary which really tries to pull together any of the information that's available on the thickness and how that thickness might vary across a region, across a sub-region, but also looking at key things about the lithology. So for instance, if the BGS have identified that for certain lower strength sedimentary rocks in that area, there are large amounts of limestone bands within them, we would identify that, because that may affect the ability for that particular potential host rock to actually host a GDF if it's got a lot of limestone bands through it. But we do make the other really strong point in that situation that even where individual clay-rich rock layers may not be thick enough or have the right lithology throughout to host a GDF themselves, a geological disposal facility themselves, they may well contribute to the safety of a geological disposal facility. I'm going to say GDF. You all know what that is, because each time I say it, it's drying out my throat more. So, the safety of a GDF in rocks below by potentially providing the separation between deep groundwater and surface groundwater systems. The other thing we identify is that if lower strength sedimentary rocks, mudstones, etc., occur in the lower part of the depth range of interest, we do make the point that this may be a challenge from an engineering point of view. For evaporites, we pretty much talk about similar things. We look wherever there is any information in terms of thickness and in terms of the actual presence of halite, rock salt, because one of the things that BGS were only able to do over the country was not necessarily say, they could say, yes, there are definitely some evaporite sequences here, but the information isn't available to say whether there's rock salt or halite in there, and that's the sort of one of the main focuses in terms of safety. That makes a very good, potentially makes a good host rock, and what our safety cases have been previously considered for in terms of certainly on the international scale. So that's all I really want to say about evaporites. Now, for higher strength rocks, and Dave has already alluded to this somewhat, there's a much greater range of potential rock types in the UK that could be higher strength host rocks. But equally, the amount of information that actually suggests, whether how likely that is a lot less available, particularly where they're at depth, because it's largely in these rocks, the way water moves through these rocks is through fractures. And to actually have that information at a national scale for rocks that are buried down at 200 to 1,000 metres, there's not a lot of information around. For rocks like granites, intrusions, volcanic type rocks, we could be reasonably confident that it is pretty much, it's just the fractures that are going to be the issue there, and we can address that when we come to look. But for some of the metasediments, and particularly the lower Paleozoic rocks, this question of whether the mudstones, for instance, have actually been changed enough that they've developed a slaty cleavage, etc., is something which, particularly where they're buried by younger sediments, it's very hard to know. And although the BGS have done their best with the information available, there are parts of the country where they've had to sort of say, well, we've not identified a potential host rock here, but we're kind of saying in there, but that's really because there isn't the information. And therefore, we just put that flag there that in certain areas, although we can't definitely say there is a potential host rock there may be. And possibly drilling in the future could identify that. So it's just really to pick up on that side of things. So that's all I really want to say about rock type. Rock structure, I think largely it's been covered here in terms of, so looking at both faulting and folding. In terms of faulting, the two key things that we talk about in terms of the relevance to safety, the first one is the fact that faults are likely to affect the way that groundwater moves through the rock. That can either be by providing a permeable, faster pathway for groundwater to move through, but equally, they can act as barriers. And there are good examples in the UK where faults act as barriers over large distances to the point that they actually compartmentalise aquifers over regional areas. So that's something that, and in fact, many faults you will see as you move along there, either up and down them or along them, they will be permeable in one part and a barrier in other parts. So we recognise that as well. And the second point is that a fault, as alluded to by Dave, will break potential blocks of host rock into smaller blocks and actually maybe salami slice them in places if there are a lot of faults. And that may make it very difficult for us to actually come up with a design of a geological disposal facility that can be safe and can actually be practical. So that's something that we would need to know about. But I think the important point, and one of the key things that we stress in every single sub-region report, is that although this exercise has only identified the big faults, what we will need to do when we actually come to looking at any region is, for the geological setting and the nature of host rock we're looking at within it, we need to know what is the relevance of faulting to that particular system in terms of safety, and then design an investigation programme that collects the relevant information needed for the faults within that context. For folding, really it's the same two main features there. That first of all, it can lead to very steeply dipping and contorted geometries of potential volumes of host rock, which could lead to making it very difficult to either make a safety case or even come up with a design that will fit into it. And then the other side of it is that as these rocks are contorted, particularly in the tight axes of some of these folds, it may lead to greater permeability due to fracturing, and therefore that's something that we would need to recognise. So moving on to groundwater, there's really not a lot more to say than pretty much what Fiona talked about there. The key message really, and it's something that and it comes up again when we look at natural processes, is we have to recognise that there are aquifers, because people know about aquifers, they know they get their water from it, they've often heard about the chalk, etc. But it's to get the message across that in most parts of the UK, the deepest that groundwater is actually extracted and used, and is actually fresh enough to be used for drinking water, etc., is about 400 metres. So if we have a geological setting that below that depth has thick clays providing hydraulic separation, etc., between deep groundwater and surface water, there's no reason that having an aquifer in an area would preclude putting a safe GDF at a greater depth below it. So that's one of the key things that we try and draw out in these narratives. And I think the other points about thermal springs, obviously thermal springs indicate rapid movement of groundwater to the surface. That's obviously something that wouldn't be desirable, although a key point to make there is that often the provenance of groundwater, of where that water has come to the actual eye of a spring, is often very difficult to know. Even Bath, for instance, which is such a there are lots of theories as to actually where that water comes from. So it's not necessarily very easy to say, oh, there's a thermal spring at surface, therefore this is the area that we wouldn't be able to look at. But fortunately, there's not that many thermal springs in the UK. Resources. So we've kind of looked in terms of resources. There are sort of four broad categories of what we say about resources. First of all, where there are known resources, be that coal, metal minerals, and then oil and gas, and where they've been mined or wells have been drilled into to extract the oil and gas, we can be clear that those mines, those wells, will have affected, or are very likely to have affected, the way that groundwater moves through the ground, through the rock. And so from that point of view, we would need to take those into account in any consideration of those areas. For the situation where resources are being explored for, where licenses have been given by, for instance, the Oil and Gas Authority in the form of petroleum exploration and development licenses, or coal authority licence areas, in those situations, individual licenses quite often cover a range of activities. So it could be that the people are just thinking about they might do some exploration in the future. They could be doing geophysics, they could be drilling, they could be doing some testing. What we didn't do at this stage in the process, given that it's a national scheme, is dive in and look at every single one of those licenses, find out exactly what stage it was at, given that it's very flexible, given that those licenses come and go. Broad areas of the country remain the same in terms of where there are licenses, but individual licenses change. But what we do know is that in the future, if an area were to come forward, we would go and look at all of those different licenses that are extant at the time, and we would actually understand exactly what's going on and understand what the potential is there. The third area is a slightly strange one in that it focuses particularly on where there are mines in evaporites. And the reason why we sort of say something slightly different about these is that because evaporites are soluble, the way that mining in evaporites works means that the mining technique deliberately tries to avoid making any connection with the groundwater in the rocks around it, because if you make that connection, you've got a major problem in your mine, because the water will come in, start to dissolve your resource and cause problems. So it has a very different impact, potentially, on the groundwater around compared to other mines. So we recognise that, but recognise that any existing excavations would need to be understood and taken into account should an area come forward which has mining of that nature. And finally, in terms of mining, again, it's a bit like the aquifers. A lot of people will know, well, I know there's a mine down the road. It's, you know, I walk my dog past it every day. There used to be a mine, and you guys haven't mentioned it. So what we've made sure is that all of the shallow mines are also recognised, shown on maps so that people know it. But we make the point that if they are shallow, if they're only in the top 100 metres, they're not really relevant to our work, because we don't really consider that top 100 to 200 metres, other than the way that potentially radionuclides could get back to the surface in the future. Then we don't take account of that in part of the safety case. And that digging only down to that 100 metres is not going to have a major impact on safety, or certainly the engineering side of things. So we recognise them, but we make that statement that captures that. And finally, natural processes. And again, I think largely Fiona has sort of stolen most of my thunder on that one. But really just to make the point that on the back of that report that the BGS produced for us back at 2 or 3 years ago, while a GDF would need to be sited and designed in a way that takes into account future natural processes, it's very unlikely that the scale of earthquakes in the UK and also glaciations in the UK for a geological disposal facility that's at 200 to 1,000 metres, that it would actually have a major impact from a safety point of view. The other point is, which I'm not sure came out quite as strongly, is that actually most of the UK has a similar susceptibility, if you like, to glaciation or glacial or periglacial processes or earthquakes over the timescale that we're looking. So to take the earthquake one as an example, in this day and age that we live in the last 10, 15 years, people might say, oh, well, yes, the Barla Fault, or up around North Wales, there's a lot of seismic activity. But if you then roll back to something like the Middle Ages, it was the English Channel that had more of the activity. So if that can change over literally a period of several hundred years, when we're looking at thousands and tens of thousands of years, then there's no real expectation that any one area is likely to be more susceptible to, and again, the key point is the small level of seismicity that we would need to take into consideration. And from a similar point of view, and this is important, I'm going to finish here, really, when you look at the glaciation side of things, there are parts of northern England where potentially deep existing erosion channels from previous glaciations may be more susceptible to be deepened further in the future. But that's something we would need to look at very much at the site-specific point. It's not something that would exclude a large area at this national overview. And community were to come forward and say, look at our area 50 by 50 kilometres, it would only be a relatively small part that would be excluded by that kind of feature. And so that really then comes to my final point, which is what we're really trying to do as part of this screening, if you like, is to come up with a checklist, if you like, of what would be the geological attributes we would need to consider further should a community or an interested party come forward in this particular sub-region. And at that point then, going back to the mentioning sort of the IAA guidance and IAA requirements, we would then use those very much to help us in terms of thinking about how would we design our investigations and our considerations to ensure that we've addressed everything relevant to safety. And that was really all I was going to say.
Great, thank you very much, Andy. On the same basis and recognising that whoever asks questions now is keeping us from our lunch, then put you on. Any brief questions?
Nick?
Yes, Chris.
I mean, we were asked earlier about the reaction of the incoming review panel. The Bob chapter is also here. 2 or 3 of us have been involved in discussion in the last couple of weeks, and we haven't been involved at all for the last year and a half or so. And actually, we were very impressed with how well it's come together. I mean, I think the structure of having BGS and RWM, and it's clear what their ownership is, and they both need each other, and it comes together well. I think it has moved on considerably since we last met as a formal group. And I think we are happy to record that amongst the 2 or 3 of us of the panel that's left who haven't been
Oh, that's very kind of you to say so. Thanks.
Well, on a similar note, I'm very encouraged, having watched this and had various involvements over the years from the Geological Society's point of view and offering observations and comments on plans as they've evolved. I think there was a concern going back a year or 2 that the relevant geology would be put out, and hopefully in a way that people would understand, but that it wouldn't link through to what people would need to know about the geology, to why that would matter. So it's very helpful to hear that presentation, Andy, picking up on the work done by BGS, that there's really attention being paid now, not just to, are we gathering the right sort of geology to inform processes, but also facilitating people understanding why that geology is relevant to the sort of decisions they're now going into.
Yeah. And I think picking up on that, what Jonathan's hopefully going to, I haven't actually seen the individual, but trying to then capture those messages and how those linkages work in a way that's very accessible to people is what hopefully will show some progress on this afternoon. So.
Good. Well, that's a really great start this morning. I believe that over lunch there's 3D visualization demos, BGS demos of the block models in the Arthur Holmes room, which is down the corridor, down the side of this room. So once you've got your lunch, it's not a massive room, but keep moving in and out. There'll be something great to see there. And I think that'll also be running after the end of the day,
Nick,
when we have tea at 3 o'clock.
Also worth mentioning that as well as the BGS block models being demonstrated, Jane Campbell from Radioactive Waste Management is here with, I think, 4 headsets that show some of the virtual reality presentations that we've developed over the last year or so. So they're also available for people to enjoy.
Great.
And those are in this right-hand corner of the library itself.
They're in the lower library. Yeah. Okay, so there's entertainment as well as lunch. You've got no excuse to get bored. Let's have some lunch. Back at 1:30, I think. Is that right?
Yes, that's right. Yeah.